Hello, and welcome back to Code Snippets. Today, we're going over methods because it's such a huge part of Java and programming in general. There are entire languages, and there's a genre of programming language that's dedicated to methods and functions, aptly known as the functional programming language. So, let's create a new class and just jump right into it. So I'm just going to call it methods. And I want to point out, I've talked about this before, but this main method here, as the name implies, it is a method. So what is a method? A method is just a small subset of code that is self-contained, and you can run it at any time. It performs a specific task, and it is finite. It terminates at some point. So, for example, we have this main method here. This is the method that runs whenever you execute a Java program. So it immediately looks for this main method header, which is what this line is called, and it starts running from this bracket to this bracket. As soon as it hits this bracket, the program terminates. So, if we were to sort of define a main method using the same symbols and graphs that I may be known for at this point, i.e. MS Paint, then we could do so like this. We're going to come back to that timeline of code that I've mentioned in a previous video. I think talking about loops, I brought this up. You have an A and a B, right? This is sort of the principle of the main method. You start at this one bracket right here, this bracket, this is A, and this is B, and you're just going in order, line by line. So, potentially there's code all within here, right? And this is the heart of your program. That's the meat of it. Now, let's talk about like building a birdhouse. So you have a toolbox with all your tools in it. You have a hammer, saw, screwdrivers, everything like that. Now, if you're building a birdhouse, do you absolutely have to use every single tool in that toolbox? No, you don't. Right? You can build a birdhouse just using a hammer. Or you might need a saw if the pieces aren't already cut. But you might not necessarily need a screwdriver to build a birdhouse. Or maybe you are using screws instead of nails, in which case you wouldn't need a hammer. Or maybe you're using all of them. And on top of that, not only does every tool not need to be used, but you can also use it more than once. So this is sort of the essence of methods. I can have this timeline of code right here that goes from A to B. And everything runs once, excluding loops. We're not talking about loops in this exact instance. Everything runs once A to B. Every line runs exactly once. And then the program finishes, and you've hopefully achieved the output that you were looking for. But let's say I have a little piece of code over here that I maybe want to run more than once. But I don't necessarily want to use a loop for it because I don't know when I'm going to want to run it. So for example, we're going to say this is C. Oops, I'm sorry, I don't have my pencil selected. This is C, and this is D. So A, B, and then C, D. These are two separate and parallel timelines, you could say. So you can run the code from A to B and never touch the code from C to D. But you could also say, at this point right here, let's say I do want to run the code C to D. So basically what happens is you have an arrow that points at C, and then it says, okay, run all of this code the same way that it would run A to B. Just top down, one line at a time, each line only once. Once it gets to D, then instead of going back like this, right, it wouldn't go there. It would instead go right back to where it was called. So sort of like a carrier pigeon, right? It sends a message, the message is delivered and whatever, and then the pigeon comes right back to your house. That might be a little dated, as in like 18th century dated. So the code comes right back here to where it was called, just like you had never left, and then it continues on running down the rest of your program. So this little piece right here is a method, and it can be called more than once. So let's say we call it here once, and then it comes back, and then we call it again down here, and it would point right back up to the start again, just like it did the first time. It would run through, and then it would come back to this exact spot again. So you're just sort of stepping out of the timeline for a second. If this is your main code, you're stepping out for a second, you're going into this method over here, you're finishing this, and then you're coming back. And then you run some more code, then you get here, oh, we need to do that again, so we go back to C, run the code from C to D, and then come back to this point right here. And then we finish our program. That is the essence behind methods. So if we were to look at Eclipse, this is our A to B, this main method. This is the start and the end of our program as a whole. So when we hit the run button, this is what runs. This is our main thread. So if we follow this same format, we can create our own methods. And that format is, we have something called an access modifier. Access modifier, and this is either public, private, or protected. The 3 P's of the access modifier. Did I spell modifier wrong? Who knows? Maybe there's 2 D's. Okay, I don't know what it wants from me. So we have the access modifier, which I will go over this when we start talking about classes and objects. Just for now, use public. Then we have the static keyword. So instead of having like multiple options, you can either just include the static keyword or not include it. Again, that's something that I will go over when we start talking about classes and objects. For now, if it says you need it, include it. If it says you don't need it, don't include it. Then we have our return type. So here, this is the information that gets returned. I will talk about this in just a second. The return type. So this is any data type. So we've talked about data types in the past. We have string, int, boolean, float, double, any of these. You can even return a non-primitive data type, such as an array. So if we said something like a long array, or if we said an array list of integers. These are all different return types because it's just representing some sort of data in general. Then here we have the actual name of the method itself. So this can be almost anything. You can't use specific keywords, like you can't use main because main is already in use. You can't use, well, you might be able to use public, but I'm not sure. I'm sure you can find a list of reserved keywords online that you can't name your method. And there are also other naming conventions, like you can't use a space or anything like that. So for our method name, we're just going to call it test method. And we're going to follow the same naming convention that we give our variables. So that's the lower camel case. Next we have the set of parentheses. And inside those parentheses, we have our arguments, or parameters. They sort of mean the same thing. I will be calling them parameters because that is this exact name, this particular name for what these are in this context. So the parameters dictate what information do we need to send into the method in order for it to work. Again, I will talk about that in a second. Similar to the return type, this can be any data type. So primitive, non-primitive, string, int, boolean, float, double, all of that. That can all be used as a parameter. The main difference between a return type and a parameter, or I should say, not the main difference, but a big difference, you can only have one return type, but you can have as many parameters as you want, including no parameters at all. The equivalent for no parameters as far as a return type is, if you notice this void keyword we haven't talked about before, this means no return data. So this is essentially saying null in a way. It basically just means this program will run from A to B and no data will be sent back because there's really nothing meaningful there to send back. And that's just a case-by-case piece of info that you'll have to worry about. And we'll do some practice methods so you'll understand when to use void and when you actually need to specify a return type. And then if we were to have multiple parameters, we could separate them by commas. Lastly, we have the brackets, or the body. Well, the body goes inside the brackets. So brackets and method body. So this is our formula for creating a method. So this line here, just so you know the semantics and keywords, this is known as the method header. So all of this data together creates something called a method signature. This tells Java exactly what you're looking for when you're trying to call a method. And that goes into overloading and overriding, which is something we will talk about later, once I explain what a method is and how to use it. So let's write a method that just prints out a message to the user. So we're going to start with our formula. So public, we're going to make it static, and we're not going to have it return any data. We're just going to have it print something out, so we don't need anything back. So we're going to say void, and we're going to call it test method, because that's what I said we would do here. So test method, but normally you would make it something that's indicative of what the method is actually doing. So here we might want to name it something like print message, something to that effect. And we're not going to take any parameters. And there's our method. So now we've written a method header, and it has a unique method signature, which means that there's no way Java can be confused about which method you're trying to call. So before we move on, I just want to clarify what exactly that means. The method signature is much like your social security number. It's unique for every method, and you want to make sure that it's unique so that you don't have two people with the same social security number, and then if you're trying to contact one of them about like banking information, you're not talking about two different people who happen to have the same social security number. That's not possible. So if we were to take this exact method and copy and paste it, Java doesn't like that. And you can see duplicate method in this class methods. So, or I should say class methods up there. So these two method headers have the exact same method signature. If I were to try to call one of these methods, Java wouldn't know which one I wanted to call. However, if I changed one thing about either one of these, so if I said I could say test method 1. Now it has a different name. Therefore, the method signature is different. Or, if I gave this one a parameter, int I, now the signatures are different. Because if I want to call this method, I wouldn't put anything in the parentheses. But if I want to call this one, I would put something in the parentheses. And if that's confusing, don't worry. I'll show you exactly what that means once we get this filled out. So let's just go back to one method. So here we're going to print out a message to the user. So we're going to sysout, and we're going to say hello, and that'll be the message. So if we run this, nothing happened. That's weird. It should have printed out the message hello. But if you recall, back to this beautiful chart that I made earlier, just because we have this line here, this extra code, doesn't mean it's going to run. We can make it from A all the way straight to B and never touch this, right? They run parallel to each other. So we have to tell Java that we want this code to run. This is our C to D, right? So if we were to label these, this is A to B, and this is C to D in our illustration that I made right here. So we need to tell Java, since A to B automatically runs whenever we execute a program, we need to tell it that we want C to D to run at a certain point. So the way we do that is by invoking a method call. So this is when we tell Java, go to this method right here and run the code inside of it. So the way we do it is we just call the name of the method. So that's test method. And then we need parentheses and a semicolon. So now we've told Java, look for a method called test method that doesn't take any parameters. So basically the parentheses need to match. In this case, we have empty parentheses, and here we have empty parentheses. So they match, and the names match. So we're all good. Now if we hit run, the message has been printed. Which means if we call test method a second time, just like we said we could do earlier, we can call methods as many times as we want to, we should see the message printed twice. Sure enough, that's exactly what happens. So if you notice, we only wrote this line once. We only told it to print out a message once, but we called the method itself twice. So this code actually ran 2 times. So that's what's nice about methods. You have a nice packaged up piece of code that you can call as many times as you need. So you don't have to write extra code over and over and over. So let's do something a little bit more useful rather than just printing out a message. Let's say we wanted to do some multiplication. So let's start up our formula again. Public, static. But this time, we're not going to print out the answer. We're going to have the answer sent back to where the method was called. So this time, the return type will not be void because we want information to come back. So let's say we're going to multiply some ints together. An int times an int will always give you an int. So our return type will be an int. So an easy way to think of what the return type would be is, what sort of answer are you looking for to the question you're asking? So if we were to compare this multiplication method to something in real life, let's say you have a friend in real life named Stacy, and Stacy is really good at doing mental math multiplication. So you can ask her, what's 46 times 27? And without even thinking about it, she'll give you the correct answer. So it's much faster to ask Stacy than it would be to ask Ryan or something like that, right? Maybe Ryan isn't as good with that kind of stuff. Or it might be faster to ask Stacy than pull out your phone or a calculator and do the same exact problem, because she just happens to know it off the top of her head. So if you were to ask Stacy, hey, what's 26 times 42, that those two numbers, 26 and 42, those are your inputs. And the output that you'll receive back will also be a number, an integer, right? Whatever the product of 26 and 42 would be. So if we finish up this method, multiply int a and int b. So this means the name of the method is multiply, so this is just what the method is doing. It takes two parameters, two integers, a and b. It's going to take these two numbers and multiply them together, and then the result will be an int. So you can sort of read this backwards if you want to, if that sort of makes it easier. So if we ask Stacy, what's 26 times 42, she would then take those two numbers, multiply them together, and then tell you the int answer. So you want to make sure that this int is truly indicative of what sort of data type you'll be receiving. So for example, if you multiply two numbers together, the answer is not going to be a string, right? That doesn't make sense. We want it to be possible and probable in whatever state we're creating. So we are getting an error. Now why is that? What does this say? So this method must return a result of type int. So it's recognizing that we have an int return type, but we're not actually returning anything. So we need a new keyword called return. So return is useful for a couple things. Number one, it's needed whenever we have a non-void return type. So whenever this third or second, if there's no static keyword, whenever this keyword right here, right before the name of the method, if this is void, we don't need to say return. But if it's anything other than void, we do need to say the word return. Specifically, we need to return some int, but we don't know what. So what we're going to do is we're going to say int c, and we're going to multiply a and b together, just like that. So now we've created a new variable that is an int type variable, and that represents the product of a and b, which just so happens to be the exact goal of this method. So we're going to return that variable's piece of data. Whatever number that we just got from multiplying a and b, we're going to take it and return it. So let's say this is the multiply method. We have two numbers, a and b, not to be confused with a and b, I suppose. Let's say we're multiplying 10 and 3, just like that. So the 10 and the 3 are going to be sent over to C, like that. And then somewhere in this line, 10 is going to get multiplied by 3, and we're going to get 30. And so if we look at our code, 30 would be C, if A is 10 and B is 3. So 30 is C, and that gets returned. So we're going to take 30, and we're going to send it back exactly where it just came from. So this is our method finished. This is our complete multiply method. Again, if we were just to run it, nothing would happen because this method is never being called or invoked. So again, if we want to call it, we would just say multiply, and then we need to pass in two ints, right? We need to pass in an int a and an int b. Now it's important that you realize whatever order you type in the parentheses up here, it will be the exact same order that appears in the parentheses down here. So for example, if I type in the numbers 10 and 3, because it lines up, 10 is the first int, and a is the first int, 3 is the second int, and b is the second int, then a will equal 10, and b will be equal to 3. And we can prove that by performing a quick sysout. we can say that A is equal to A, and B is equal to B. So if we run this, sure enough, A equals 10 and B equals 3, exactly the way that we said it would be set up, because the order matters. Now, it didn't print the answer. It never said what C was, right? Even though we know it's 30, what if the numbers were 26 and 42 and you really did need to know what the answer was? Well, the reason nothing happened is because when we say return C, we're not printing it out. We're saying take the value that C stored when it multiplied A and B, take this value and return it back to where the method is called, which is right here. So essentially what happens is this line right here, this entire multiply 10 comma 3, this turns into the number 30. So essentially in your head, you can just replace this tiny line with just the number 30. So anything you can do with the number 30, you can do with this. So for example, we could say int num equals 30, right? We could also say int num equals multiply 10 comma 3. And those are both perfectly acceptable. So now we've taken this method and whatever result that we get from it, we're going to assign it to this int variable called num. So if we print out the result that we get from num, and we're going to comment these two out because we don't need them anymore, we get 30. So now the answer has been printed out. So the result gets returned back to where the method is called. So actually here we're running the method twice. Here we run it and it multiplies 10 and 3, and then 30 gets returned back to here, but nothing happens to it because we're not doing anything with this line. Then we call it a second time, but this time we're taking the result and we're going to store it in this variable called num. And of course you can cut out this middleman here where we say int num equals multiply sysout num. Instead we can just say sysout and then the method in its entirety. Just like that. And that's perfectly acceptable as well. We run it, sure enough we still get 30. Now, what happens if we use the return statement in a void method? Or what happens if we use multiple return statements? What happens? Let's find out. So first let's try saying, so we return C, and then we're going to print out a message just so you know the method has finished successfully. Just so the user knows that we did in fact get the number that we were looking for. Okay, why is this red? Unreachable code. Okay, so anything after this return statement is unreachable because as soon as we hit this return statement right here, wherever it is, we're going to drop everything and immediately go back to where it was called. So whenever you hit a return keyword in a method, that method will stop whatever it's doing. It won't do anything else, and it'll go straight back to the method call. So if we go back to our code, as soon as we hit that return, no matter what it's doing, it's going to stop everything, and it's going to immediately go back to wherever it was called. So in this case, it would be both of these lines, whatever one happens to be running. So this line will never actually run. It'll get skipped over every single time because we're always going to hit that return statement. So what if we had multiple return statements? Well, how would we do that? Because as soon as we run into one, that means the method's going to stop. Well, let's say we want to return only specific information. For example, let's say instead of multiplying, what if we want to divide? So we're going to change this to divide, and we're going to pass in two numbers. Let's say we want to divide 30 by 3. So now, of course, divide doesn't exist, so we have to make it. So let's write a new method. Now, instead of an int, we're actually going to return a double, just so this is easier. And then we're going to take two doubles, A and B. And of course that means these need to be 30.0 and not 0, but 3.0. There we go. And of course we're getting a red line because we're not actually returning anything, even though we have a non-void return type. So I'm just going to put return null for now, just as a placeholder, so we're no longer getting that error. And you see there's an error for this because a null is not a double, so we're going to get an error for that. So instead of saying null, then let's just put in 0.0. Okay. So if there was one instance where we wouldn't want to divide A and B, so if we said, not an int, but double C equals A divided by B, right, this should work fine, and then we can say return C. So what's the problem with this? Well, what happens if the user enters a 0.0 for the variable B? Well, then we would get an error because you can't divide A by B. Or you can't divide a number by 0. So what if we said, if B is equal to 0, then we can display a message, cannot divide by 0. And then we can return -1. And that'll sort of be our error code. Because let's say we're in whatever context we're dividing, we can only enter positive numbers. So it wouldn't make sense that we would ever get a negative number because any positive divided by another positive will always be positive. So if we received a negative number, we would know something is wrong. So if we hit this return statement right here, if B happens to be equal to 0, that means we cannot divide by 0, so we're going to return -1. Well, we already determined that if we hit a return, we're going to stop everything. And we're going to return back up to here. So then why are we not getting an error message here? What's the problem? Well, the fact is, we're not always going to hit this return statement because it's inside this if statement. We only hit this return if B is equal to 0. So if B is not equal to 0, we're not going to hit this. Instead, we're actually going to move forward with the division, and we're going to return that result. So if we run this, we get the number 10.0 because that's 30.0 divided by 3.0. Now if we said 30.0 divided by 0.0, now let's see what happens. Okay, so now we got a message that said we cannot divide by 0. And then it returned the result of -1.0 instead of whatever error would happen if we actually just tried to divide by 0. So let's do that. Let's see what would happen if we commented that out and tried to run it. Okay, so infinity. Well, that really doesn't make sense. First of all, it's not a number. Infinity is more of a concept than anything. And this doesn't help if we're trying to do some sort of calculation, because you can't say, like if we want to, instead of print out that number, if we want to store it in a double, we could say double result equals, and then divide these two numbers. So if we put this back to 3.0, oops, my bad. If we put that back to 3.0, then we could say print out result plus 1. And we'll see what that does. So now we printed out 11, because 30 divided by 3.0 is 10, plus 1 is 11. Now let's put that back to 0 and see what happens. Okay, so we got infinity. And if you add 1 to infinity, you still have infinity, because it's not a number, it's just a concept. So this doesn't make sense. This already is going to mess with all of our calculations if we're trying to do something business-wise. So if we keep this code back in, right, now we're going to check to make sure that b is not equal to 0 before we try to divide anything. So if we run it, cannot divide by 0, and now we have a -1 as the result. -1 plus 1 is 0. But this is something we can test for, right? We can say if result is equal to -1, then we know something went wrong. Else, print the result plus 1. So now we know if we do get a 0, or a -1 for the result, it's not going to print out -1 plus 1, because we know that the calculations were mistaken. If you get an infinity as your result, there's really no way to test for that. You can't say if result is equal to infinity. It just wouldn't work. So this is one way we can sort of handle that. So there's a lot of versatility that you can have inside of methods. That's sort of what I'm getting at with this whole experiment. And you can sort of control in what ways methods communicate with each other. So these are the basics of methods, and we'll be talking more about methods in the next video as well.